project is sponsored by PCBWay. From concept to production, PCBWay provides cutting-edge electronic design solutions for global innovators including hardware design, software development, mechanical design, product testing, and certification. PCBWay engineering team consists of experienced engineers in electronics, embedded systems, and product development. They successfully delivered hundreds of projects across industries such as medical devices, industrial automation, consumer electronics, smart home, and IoT. Also, don't forget to participate in the 8th project design contest until January 31st, where you can compete in 3 categories: electronic project, mechanical project, or AI/OT project. PCBWay has all the services you need to create your project at the best price. Hello, Winamp is one of the most iconic and historically significant digital media players ever created. It becomes synonymous with the MP3 revolution and the early days of digital music ownership. It supported a wide array of audio formats, including MP3, AAC, WAV, and WMA. You are probably familiar with its classic style, a simple small interface that resembled a car stereo head unit, complete with a separate equalizer and playlist window. Recently, the source code of this player was released on GitHub, and after that many enthusiasts created versions of this legendary player for multiple operating systems. Incredibly intuitive is the idea of Rodrigo Mendes to create a practical front panel for an audio amplifier in the style of such devices from the end of the last century based on this player. In addition to its beautiful appearance, this front panel is also very functional. The original device is based on 7.9-inch ultra-wide HDMI touch display with a resolution of 1280 on 480 and a Raspberry Pi small single-board computer. I currently have an ultra-wide LCD with a built-in Raspberry Pi5 intended for a post-system project, so I decided to use this existing hardware. The difference with the original project is in the resolution and dimensions of the display, namely my display is 9.3 inches and has native resolution of 1600 on 600 pixels. My knowledge of Raspberry Pi operating system is quite limited, so I had to spend more time searching for information on the internet. Therefore, the explanation and terminology for the procedure for implementing this project will be at the lowest level, which would be a great advantage for absolute beginners. The following is a sequential presentation of each part. First, on the Windows PC, we need to create an image of the Raspberry Pi operating system on an SD card. For this purpose, we need an SD card with a capacity of 8 GB or larger. Then we need to download the Raspberry Pi Imager software from the given link. This is Raspberry Pi Imager, newest version. Now we need to select the Raspberry Pi model. In my case, that is Raspberry Pi 5. Press next. Now next is the operating system. We need to select a port of Debian Bookworm according to the author's recommendations. Press next, then we select the storage device. Again next, and I will skip customization and write the image of the operating system on SD card. Now we put the prepared SD card in the Raspberry Pi. At first I will use a large monitor, mouse and keyboard for easier work and visibility. We also need to enable internet access via network cable or Wi-Fi. When the operating system boots up, open the author's GitHub page in a browser where the installation is explained in detail. This is the author's GitHub page. First, we need to clone the project from GitHub to the local storage with the following command on terminal window. Open the terminal window, git clone, and paste the given link in the GitHub. Now it's done. Now a folder named Linamp should appear in the file explorer. This is our folder Linamp. Next, we need to open the terminal window again and with cd linamp command. Then we copy the instructions from GitHub into the terminal and press enter. Instruction for Debian Bookworm. Now the installation of support libraries and environment, as well as the program itself, is being performed. This will take a few minutes. Then we go to programming, and we will see that new programs have been installed. Python 3.1 with 3.11 and program Qt Creator. We start the Qt Creator, open project. We need to find Linamp folder and activate the file named cmk.txt. Now press configure project. And waiting a few minutes. Now we go to run, and after a certain time the program will start. If the Linamp program appears, it means that we have successfully installed it. Let's see the result. Few seconds. And this is full screen of Linamp Player. As you can see from the above, the installation is extremely simple. However, if you try to install it on another version of the operating system, such as the latest operating system, for example, a port of Debian Trixie, you will notice that it is almost impossible due to the certain incompatibilities of the libraries and the environment. Now it's time to connect the original touch display. We start the program in the same way as before. Programming, Qt Creator, then go to Open Project, folder Linamp, cmake-list.txt. Press play button. As you can see, Linamp does not cover the entire screen and there is empty space on all sides. The reason for this is the fact that the author created the program strictly for the resolution of 1280 on 400 dots, and specifically on this display, resolution is 1600 on 600 dots. It is very simple to set the required resolution on this display. We go to Preferences, Screen Configuration. On HDMI small widescreen, right click and resolution. Here we need to choose the desired resolution of 1280 on 400 pixels. However, the required resolution is not here. In order for the required resolution to appear, we need to make certain changes to the operating system kernel. For this purpose, the following procedure is used. In the terminal window, we write the following command: sudo nano boot firmware cmdline.txt. Now, before the beginning of the line, this is that line, we write this command: video HDMI A1 and desired resolution. This is refresh rate and leave a space. So this is that command. We have mistake here. Okay. Next, press Ctrl plus O to write out the file, then press Enter to confirm the file name, and press Ctrl plus X to exit nano. Now reboot Raspberry Pi to apply the change. Sudo Reboot. After starting, the display menu should have the required resolution. Let's see that situation. We go to Preferences, Screen Configuration, Resolution, and now we have our desired resolution. Again, this is our desired resolution. Apply. OK. Now we start the software, programming, Qt Creator, open project, LINAMP, cmk-list.txt, press run button, and this is full screen LINAMP software. One very important note, Raspberry Pi 5 does not have a standard audio port, but the sound goes through the HDMI protocol. This means in practice that this program will crash on startup unless there is a standard audio device. For this purpose, I installed this small cheap USB audio accessory. Actually, this is USB sound card. After assembling and testing the device, I had very unpleasant experience. Namely, out of carelessness, I mistakenly connected 12 volt instead of 5 volt, and at that moment I smelled the smell of burnt electronic components. Raspberry Pi 5 was irreversibly damaged. This power chip is damaged. On the display, I discovered a small SOT 23556 chip on displays marked LPS FTE F1, which was completely shorted, and at the same time I could not find any information about it anywhere. According to the components around it, this Schottky diode, coil, 1 ohm resistors, it was almost clear that it was a boost chip that rises a voltage from 5 volts to the appropriate level to power the LED backlight. So in place of the cutout of the Schottky diode here, from the boost converter circuit, I connected 12 volts with a limited current of 10 milliamps. The backlight appeared with a very weak intensity and flickering. Then I gradually increased the limited current to 60 milliamps, and I got a completely normal LED backlight on the display. Then, as a more elegant solution, I connected a cheap external boost converter module from 5 to 12 volts, and with an LM317 I limited the output current to exactly 60 milliamps with this 19 ohm resistor. This way I got the display back fully functional, although its price is around $100. Now it's time to install the device in a suitable box and demonstrate its functionality. For this purpose, I made the box from PVC material and covered it with colored self-adhesive wallpaper. This is what the finished product looks like. Inside is the Raspberry Pi 5 plus the HDMI touch display module, and on the back panel is small stereo amplifier module PAM8403, but of course a more powerful amplifier can be installed. Here is the 5 volt 5 amperes input voltage connector, and as well as a small toggle switch. The volume potentiometer is a part of the amplifier module. As I mentioned earlier, for the software to work on Raspberry Pi 5, you need to add an external USB sound card with appropriate input and output connectors. Its output is connected to the input of the small audio amplifier. I start the device with a small switch on the back and wait for the operating system to boot. It is very easy to adjust the option for the program to start automatically, but I left that part out so that I can gradually show you how to turn it on. It is easier to go to the LINAMP folder and start the shell script there directly. Start.shell. So this is what the active audio amplifier looks like with the Winamp interface. All buttons, the sliders, the volume and balance potentiometer are responsive to touch. I connected two sound boxes to the output of the audio amplifier. The playlist button opens a window for sorting the playlist just like in the original software. We need to select the folder with music, and we can edit the playlist with drag and drop. Now we can press edit, and with drag and drop we can arrange playlist. When playing a song, the equalizer is active, and the long slider shows the duration and elapsed time of the song. Just like in the original, with this slider we can select the moment until the song is activated. By pressing the Winamp logo, we enter a menu where we can select one of 4 sources from which the sound would be emitted. File, this is this particular case. External USB CD player, Bluetooth source like a mobile phone, or Spotify. Below I will present you all these options. Now the phone is connected to the LINAMP amplifier, and we can choose music to play on this device. Now I will present you with a special case where I will use a stereo tube amplifier at the output as a symbiosis between very old and the latest technology. And finally, a short conclusion. This project perfectly fuses the iconic Winamp software with modern Raspberry Pi functionality, where every original Winamp function is fully touch responsive on the finished product, demonstrating a successful and practical tribute to a legendary media player.